Hi everyone, in this video we will take a look at 2.8, the distance formula, and also circles. Okay, we have several objectives. First, let's look at finding the distance between 2 points, and then use that to write the standard form of a circle. And then given the center and radius, we're going to find the those two values using the equation in standard form. And then lastly, convert the general form of a circle's equation to standard form. Okay, let's first take a look at the distance formula. Okay, the distance formula is used to calculate the distance between any 2 points, x1, y1, and x2, y2. So if you have these 2 points, put this, here's x1, y1, and x2, y2. What we can do is use the idea from the Pythagorean theorem, where if you have a right triangle, I'm going to make a right triangle here. And here's a right angle. The length of this bottom side is the difference between your second x value and your first x value. Here, the length of this part of the triangle is y2 minus y1. Now, if you think about what the Pythagorean theorem, or this side of the leg of the triangle, it was a squared plus b squared equals c squared. So if we call this d, or the distance between those 2 points, d squared rather, is the x2 minus x1 squared plus y2 minus y1 squared. Now that's one way of looking at the distance. If we want to get distance by itself, we can take the square, the power 2 off by taking the square root of both sides. And then that would give us d is equal to the square root of the difference of x2 minus x1 parentheses squared plus y2 minus y1 squared. Okay, so you should write this formula in your notes and label it the distance formula. Okay, let's do some practice finding the distance between these 2 points, -2, -6, which is located right there. -2, -6, and 4, -5. Okay, so we're trying to see how long is this length, which we're calling d. Okay, so using the distance formula here, we have, let's actually just rewrite the formula, x2 minus x1 squared plus y2 minus y1 squared. Let's label these points so we don't get confused. Here, -2 is x1, -6 is y1. 4, we have x2, and then -5 as y2. So we plug these values in. x2 is 4, minus x1 is -2, squared plus y2 is -5. We're going to subtract y1, which is -6 squared. And we know from previous sessions where if we have a minus a negative, that becomes a positive. So we actually have 4 plus 2, which is 6. And then -5 plus 6, which is +1. So we have 6 squared plus 1 squared still under the root. 6 squared is 36. 1 squared is 1. We have the square root of 37. If we put that in the calculator, let's round to 2 decimal places. It's about 6.08 units. And you can see it's about 6 units long, but a little longer. Okay, we're going to try a different problem. One more. Find the distance between 0, -2. Here's 0, -2, and 5, 3. 5, 3. Okay, find the distance between these two values. Oops, trying to draw a straight line. Okay, here it would be a good idea to pause the video to see if you can calculate the distance on your own. So use the formula again, d equals square root of x2 minus x1 squared plus y2 minus y1 squared, and calculate the distance. Okay, I hope you had a chance to calculate on your own. Let's check. We have 0 as x1, -2 is y1, and 5 is our x2 value, 3 is our y2. So let's substitute those values into the formula. So we have x2 being 5 minus 0 squared plus 3 minus -2 squared. We have 5 squared, and then 3 minus -2 again is 3 plus 2, so that's 5 squared. 5 squared is 25 plus 25. We have the square root of 50. We can split up square root of 50 into the square root of 25 and square root of 2. Because square root of 25 is a perfect square, we get 5 root 2. And plugging that into later, we get 7.07. So in the homework for my lab, you are expected to put the root in your homework, and then also round to 2 places. Another way, if you have a graph, is to use the Pythagorean theorem, which is here if we draw a right triangle like we did before. You have this triangle here. Think about how long this side of this triangle is. You can see it's 1, 2, 3, 4, 5 units long. And this is also 1, 2, 3, 4, 5 units long. And if we label this D, these two legs, 5 squared plus 5 squared, is equal to d squared. We know 5 squared plus 5 squared is 50. That's d squared. And same idea, we square root 50 both sides, and we would go, right, we would end up there. And so if you have a graph, you can also apply the Pythagorean, which is basically the distance, how the distance formula is derived. Okay, using that idea, let's develop the standard form of a circle's equation. So here's a circle with center. We call the center value x, y values h and k. So h is your x value of the center, and k is your y value of the center. You can see how the center is located right in the middle of the circle, and the radius is the distance from your center to any point on the circle. And we call that r. Okay, so if you think about the distance, this is, remember, the r's distance. And we said the distance, right, the formula is d squared. Actually, let me just put, was x2 minus x1 squared plus y2 minus y1 squared. If we think about hk as 1 point, and xy as a second point, and if we label h as x1, y1, and xy as x2, y2, we can substitute that. And instead of d, it would be the radius squared, x2 being y minus h squared, plus y2 would be y minus k squared. And that is your standard form of the equation. It's derived from the distance formula, because we take radius as the distance between the center, the first point, to any point on the circle, xy. Okay, let me just write again that the center is h comma k, and radius is r. Okay, so using that, make sure you have that down in your notes. Let's find the standard form of the circle with center 2, -3, and radius square root of 5, and then let's graph this circle on this coordinate plane. Again, the standard form of the circle from the previous page is r squared equals x minus h squared plus y minus k squared. And we know the square root of 5, that's our radius. So let's just label that radius as square root of 5. And our center point is 2, -3. That's our HK value. Okay, so let's plug it in. R is square root of 5, so we have square root of 5 squared equals x minus the x. We don't substitute anything in for that, but we're going to substitute h or 2 in for h. So x minus 2 squared plus y minus k is -3 squared. We're almost done. Square root of 5 squared is just 5 because power 2 and square roots cancel each other out. We have x minus 2 squared plus double negatives become plus sign, y plus 3 squared. And I know in the past, whenever you see x minus 2 squared, right, you were required to FOIL, but for the standard form, you leave it in parentheses squared. So this is the standard form, x minus squared plus y plus 3 squared equals 5. So no need to FOIL for the standard form or expand that expression. And so here, if we graph the center at 2, -3, here's the center, and square root of 5, the radius, if we calculate that in the calculator, that's about 2.4 units wide. And so I'm going to go up 2, a little bit over between 2 and 3, and then to the right about 2.4 units. And then oh, here it is. So 1, 2, about here, and down here. And so if we draw a circle, there is more or less a circle with center 2, -3 with radius square root of 5 or 2.4 units wide. Okay, let's try another one. Number 4. Actually, pause the video and try to see if you can do this one on your own. Find the standard form of a circle with center -6, 0, and radius 7. And then when you're done, check back. Let's check back the solution together. And also graph. Okay, so here we go. I hope you had a chance to look at it on your own. So here's the center -6, 0. I'm going to label that HK, and your radius is R. So label that, then we have the standard form R squared. Let me just write it one more time. X minus H squared plus Y minus K squared. We have R squared, so R is 7 squared equals X minus H, which is -6 squared, plus Y minus 0 squared. That double negatives make that a positive. 7 squared is 49. We have X plus 6 squared plus Y minus 0 is just Y squared. That's it. That's the standard form. You stop there. Again, no need to expand X plus 6 squared. Just leave that in its parentheses. And let's just graph this -6, 0 with radius 7. So I'm going to go up 2, 3, 4, 5, 6, 7 up, and then right 7 units, down 7 units, and to the left 7 units. It's off the coordinate plane, but you guys get the idea. So here, my circle is not so perfect, but here's a standard form with circle -6, 0 and radius 7. Okay. Now let's do the opposite. Let's determine the center, radius, and domain and range of the circle if we're given the equation. So we have to pull this information given the equation. Okay, so we got this, we have to find the center of the radius of the circle, whose equation is X plus 2 squared plus Y minus 4 squared equals 9. Then also identify the domain and range, and we'll put the graph on this coordinate plane. So X plus 2 squared, and then Y minus 4 squared, not really except just copying it down. The center, we can get the X value of the center by looking at this value. Remember, the formula was X minus H. And so if we want to undo this plus sign, it would have been X minus -2 squared plus Y minus 4 squared. That wouldn't change, equals 9. So you can see that H, or the X value of the center is -2. So I'll write center, it's -2. And the y value is just a 4, because you don't count the minus sign. Another way to think about it is just take the opposite value of what you see in the parentheses. So you can see x plus 2, then the center must be -2. You see y minus 4. You can say the center, the y value of the center is +4. So there's the center. Radius we can get from this value. Remember that value is r squared equals 9. Now, if we want to solve for r, we can take the square root of both sides and we get r is equal to 3. So there's our center, -2, 4, and our radius, 3. And if we were to graph this, -2, 4 would be located there. Radius 3 means we would go up 3, to the right 3, down 3, and to the left 3. And then we could draw this circle. Okay, so I'll just label this -2, 4. And how we can determine the domain and range are what's the furthest x value that you see for this circle. And if you can see here, the most left x value that we see is here, -5. And then the furthest x value is 1. So there's the domain. The range is the lowest y value to the highest y value. You see the lowest y value is +1, and the highest y value is 7. So there's our range and domain. And it's helpful to have a graph, and it helps you to determine the domain and range. Okay, let's try number 6. Finding the center and radius of the circle whose equation is x squared plus y minus 5 squared equals 16. Also pause the video and try this one on your own. And it's a really good practice that you try it out yourself before watching someone else walk you through it. So pause the video at this time and try this one on your own. Okay, so number 6, we got x squared plus y minus 5 squared equals 16. The center, you see there's nothing being subtracted from the x, so the center for the x value is 0. The y value of the center is 5. And we have 16 as our r squared. And so let's take the square root, and r is equal to 4. So we got our center, 0, 5, r is 4. So let's graph that so that we can determine the domain and range. 0, 5 is located at that point. So again, we draw the circle by using the radius. It's 4 units for the radius. So I would go up 1, 2, 3, 4, and then go to the left, 1, 2, 3, 4, go to the right, 1, 2, 3, 4, and 1, 2, 3, 4. Okay, so using those 4 points, we can graph a nice circle. Now for the domain is the leftmost x value, which is -4 to +4. So those are the x values of the circle. The range goes from the lowest y value, which is, it looks like, did I go down 4 from here? Looks like 1 to 9. Okay, so I hope you got those values. And if not, you now understand how to get the center, radius, domain, and range. Okay, last part is now going over to the general form of the equation of the circle. The general form is different from the standard form. Remember, we just worked with the standard form. The general form, the equation of a circle, is x squared plus y squared plus dx plus ey plus f equals 0. D, E, F are just numbers. They're just real numbers like 7 or 5. The problem with this general form is we cannot easily identify the center right? The standard form, you can look at what the x value and the y value of the center are. But this, we have no idea. We can't tell what the h and k are or the radius. So what we need to do, if we're given the general form, we must convert it into standard form to identify the center and the radius. So this one takes a little bit more work, but it's really not too bad. Okay, so let's look at 7. Here, 7 is, this is in general form. Let me actually move this over. And we need to determine the center and radius of the circle, then graph. So we got x squared plus y squared minus 4x minus 6y minus 23 equals 0. As given, we have no idea what the center and radius are. So we're going to do some manipulation using algebra. So we force it into standard form. And how you're going to do this is first bring down the x squared and then put the negative 4x next to it. And then what you're going to do is leave space. And then write the y squared plus y squared, and then the minus 6y, and then leave some space. Okay. Actually, I should have done one step before that. I moved a little, I skipped a step. This number that's by itself without any variables next to it, you're going to add it over to the other side. So adding 23, we cancel negative 23, and on the right-hand side, we get 23. Okay, so what we're going to do is, this process is called completing the square, where remember, our goal is get this looking like x plus or minus some value squared plus y plus or minus some value squared equals radius. And to complete the square, what we need to do is get it into parentheses, parentheses, and parentheses, parentheses, where you have x here and x here, y here, and then some value. Okay, to do that, right, these values that go in these factors or parentheses need to add to the middle term, and these two numbers multiplied is going to give us what we're going to put in the box. And so because we're splitting up negative 4 into these two spaces, what we're going to do is take negative 4 and divide the middle term. Divide negative 4 by 2. Okay, that is going to give us negative 2. That's going to go here, those two values. So you know, okay, negative 2 plus negative 2 does give us negative 4. So then what goes in this box? Well, negative 2 times negative 2. This value squared, negative 2 squared, will be what goes in the box. Because remember, when you do FOIL, right, the last terms have to multiply to what we put in the box. So negative 2 times negative 2, or squared, negative 2 squared, is positive 4. Okay, and if that's the case, then x minus 2, we can convert that or combine that as x minus 2 squared. Same idea for y. We look at y, I'll use purple this time. Negative 6y, if we break that up into the factors, negative 6, remember we're going to divide that by 2. We're going to get negative 3. So we're going to put negative 3 here, negative 3 here. And what goes in this box? Well, it's negative 3 times negative 3, which is positive 9. Okay. The fact that we added 4 and added 9 doesn't balance the equation. And so we have to add the 4 and the 9 to the right-hand side as well. Okay. 23 plus 4 is 27 plus 9. That's going to give us 36. And let's complete this. Y minus 3 times y minus 3 can be condensed to y minus 3 squared. We got 36. So there's our standard form. We got the standard form of the equation. And now you can see, okay, what is our center? Our center is positive 2. Y value is positive 3. With the radius, a radius squared is 36. So if we take the square root again with both sides, we get a radius of 6. Okay, we're just going to graph that 2, 3 and go up 6, and then to the right 6, to the left 6, down 6. And so our center value at 2, 3 with radius. Okay, this one I think we should definitely practice. So let's try the next one. Let's try this one, 8. And again, I would like you to try this one on your own before watching me go through it. And so try it on your own first. That's always the best way to learn. Try it on your own, make mistakes, and we'll compare answers together. Okay, so let's try this. I hope you try it on your own now. So we're going to write x squared, right? All the x terms together minus 8x plus, we don't know what's going to go there, leave a blank. And then you're going to put y squared. Oh, I forgot this step again. We got to add the number on the other side. Okay. Y squared plus, there is no other y term. And so we're just going to write equals 9 because there was no other y term. Okay, so remember our goal is to get this to x something squared plus, looks like y squared is already by itself. And then we don't know what this value is yet. Okay, so again, remember our goal is to get it down to x and x. And what goes in here is we take negative 8x and divide by 2. That's going to give us negative 4. And so that's going to go here, negative 4, negative 4. Now we can condense that and write x minus 4 squared. So what goes in this spot? Well, if you multiply negative 4 and negative 4 together, that's going to give us 16. So that is positive 16. Okay, y squared is by itself. There is no other y term, so we don't need to do this unfactoring process for that. And because we added 16 to the left, we have to add 16 to the right. And 9 plus 16 is 25. Okay. At this point, we should be able to identify the center and radius. The center is positive 4. Y value, there's nothing being added to it, so its y value for the center is 4, 0. Our radius, we take the square root of 25, is 5. Okay, so 4, 0. We go up 5, to the right 5, left 5, and down 5. Here's our circle. Okay, so for these types of problems, you're going to get more practice for this week's assignment. So just make sure you follow these steps and you should be able to find the domain, the range, the center, and the radius. Okay, let's look at the last problem together. Number 9, find the solution set for the given system. X minus 5 squared plus y plus 3 squared equals 25. This should look familiar. We had done this 8.4 for systems of nonlinear equations, and we had used algebra. Actually, we're going to use the graph to determine where these two systems intersect. So let's look at the first equation, x minus 5 squared y plus 3 squared equals 25. The center for equation 1 is 5. And the opposite of positive 3 is negative 3. So let's put the center at 5, negative 3. And radius, or r squared, is 25. So that's going to give us a radius of 5. So if we go up 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. I'm going to draw a circle around the center, 5, negative 3, radius of 5. And then we look at equation 2, y equals x minus 3. You also were assessed how to graph lines. And this is a line with y-intercept of negative 3, 0, negative 3. and with a slope of 1, or m is 1. We would go up 1 over 1, 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 and here's a straight line. Okay, so here we just graph y equals x minus 3, and also graph the circle x minus 5 squared plus y plus 3 squared equals 25. Okay, so let's see where these 2 points intersect. They intersect at this point, which is 0, negative 3. And also at this point, it looks like 5, 2. So the solutions for this given system are 0, negative 3 and 5, 2. If you don't like doing it using the graphic method, you can also use a substitution method and substitute x minus 3 in for this y and solve it using algebra. Okay, that's it for this section. I hope you found it helpful, and I'll see you in the next video.